Good morning, everyone. Welcome to our special session bringing women back to engineering in Should Cost Engineering. We have our esteemed guest today, Mr. Kuppusamy, Strategy Product Consultant aPriori Technologies. Mr. Kuppusamy is a senior management professional with 17 plus years of experience in the field of cost engineering and value management. And we are so proud to have him here with us today to share his valuable knowledge with us. So, over to you.
Yeah, thanks for your introduction. So, first of all, I'll welcome to all taking this great opportunity to share my experience towards to shootcasting. I think I'm going to share my screen. Then just let me know if you have any. Uh, you can see me and hear me. Yep. So today it's a great opportunity to explore the concept of shootcasting, particularly in the women's who are taking the challenge to restart the career. I privilege to take this opportunity to share my experience and what about shootcast and what is the importance. Begin to that. How many of you to how many of you interest to know about shootcasting? Yeah, please raise your hand in virtually. Okay. How many of you interest to know more about benefits of shootcasting and the importance of shootcasting? So today is the opportunity to know more about shootcast. What is shootcast? Benefits of shootcast, shootcasting process, cast out program. What are the elements in the shootcasting? What are the skills are required? Those things we can discuss one by one. Finally, we have a question and answer section. Then you can take it your all questionnaires. I'm happy to answer the things. Before starting that, I'll take a few minutes or a few seconds to introduce myself. Yeah, already they're given the brief introduction, even though you should understand uh, who I am, where is coming from, what is the background of me to talk about this shootcasting. So currently I'm in aPriori. Before that I was in TCS, then ABB and Hitachi ABB. Previous to that, Fiat Chrysler and Tata Technologies. Previous to that, HCL. A few more companies. More than decade, I'm in this cost engineering. I specialized in cost engineering and value engineering. 17 plus years I'm working in manufacturing as well as service organization to support varied product, different customers to generate their values, cost benefits with help of shoot costing. Basically, I'm a mechanical engineer and MBA in operation management, MS in manufacturing management, and few more certification in value engineering, project management, and the supply chain. Thanks for giving this great opportunity to explore this concept. So moving to next, before going and understanding the things, we should know the history. This shootcasting concept, it's rooted in cost engineering. So this cost engineering I will discuss in the final slide. So now we can more focus on shootcasting concept. This concept, it's very familiar in 1960, 1970. DOD, Director of Defense in US. Then it's slowly started and spreading to this concept, automotive and other industries. Who are the solution provider in this domain? Many solution providers are there. Even I will take it here, few more top leaders like aPriori, TCPCM, McKinsey, DFME Boothroyd, Goldrath Sear Tool, MTA Costometer, and a few more. So one of the big player, Excel based shoot costing. Excel based shoot costing, it's the origin, it's the funda of all the tools, all the process. Whoever begin to start from Excel, understand the basic, understand the formulas, understand the process. Then you can work any tools anywhere. Now moving to what is shoot costing? It's very interested question, right? Yeah. Shoot costing nothing but what should be cost of the part. One can determine using raw material, process, and overhead cost. All put together, we can say is a shoot cost. Shoot cost is a method, it's a tool, it's an approach, it's a scientific calculation. It's a management tool, cost management tool. It will be helpful to understand each and every element of the cost drivers. So before moving to the cost, we should understand what is cost, what is price. Wherever we go and see that buying the things, we can see the price tag. Cost is different, price is different. Cost doesn't determine the price. The price will determine by the market. Cost determine whether a company wants to sell the product into the market. Simple example, if you are going and buying one product in the market, they're given $10, $5, $20. That is price. But the original cost of manufacturing cost, it's different. Beyond that manufacturing cost, lot of overheads, extra packaging, transportation, many things will be included in the price. But we should know what is the true cost, what is the real cost, what is the there it will come and play the key role, this should costing concept. Moving to next. So before starting the things, we should understand what are the benefits. Yeah, I want to know should costing, but what is the benefits of doing this? It will bring you cost transparency. You should understand if you are going and buying one Coca-Cola bottle, you should know what is the cost. But we know the price, maybe $2, $4, $5. But the original manufacturing cost. If you are going and buying that iPhone, yeah, it's interesting things. You should know the cost, the transparency. At present, you cannot understand the transparency while applying this should cost. If you are the expert, you can understand what is the real cost of the iPhone. This should costing, it will be helpful to reduce the cost. Today's is the competitive market. If you are not competitive in the market, you cannot play the key role. If you want to play the key role, you should be as a competitive in the cost wise, the quality wise. This should costing concept, it will be helpful to collaborate with the supplier. If you have the should cost calculation in your table, you can go and discuss with them. Hey, this is what we did that should cost. This is what your product price. Can we discuss? If you have the breakups of the product cost, it will be easy to discuss with your supplier. It will increase your negotiation power. Without this cost calculation, you can go and discuss supply. Yeah, this is what I made. This is what I'm making that. This is my process. This is my cost. They will not willing to discuss further. There, your negotiation power is coming down. If you have the should cost in your hand, your negotiation power and collaboration with your supplier, it will be increasing. Then the final one, decision making. Whether this product I can make it or I can buy it, how you are going to determine? All the OEMs, they are not making all the products. Some product they are buying it from a outside supplier, some product they are making, some product they are getting assembled. This should it will give you the guidance, it will help you to make the decision, shall I go and buy this or shall I manufacture this? These are the few important benefits while applying this should costing concept. Many more, but I'll take it here only few things. Next, we are moving to the should costing element. Yeah, I understood that benefit. I understood that should costing. Then I understood where it is coming from, where is it originated. Then little bit in the technical part in the should costing element. What are the elements are included in the should costing? Three elements. The first one, process specific element like labor rate, machine hour rate, what is the cycle time, scrap, and tooling cost. These are the process. Each and every element you should understand before building the should cost. The second things, country specific element. There, labor rate. Yeah. If you see India, what is the labor rate? In China, Mexico, USA, Germany, you should understand the labor rate. Even the labor rate, is that skilled labor, semi-skilled, or technician? Based on the skill set, the labor rates will be vary. So you should understand the labor rate. The interest rate. Interest rate, you are buying some machineries, you are supposed to pay the interest. Those interest rate you should understand. It's not common. India is something different. Germany interest rate is something different. Imputed interest rate. Then facility cost. You have the big factory, each and every equipment they're having some kind of facility cost involving. Those things you should understand. Energy cost, if you want to build the cost model, you should understand what is the energy, what is the power I'm using, what is the electricity, what is the motor capacity, how many units I'm consuming per minute or per hour. These are the technical cost drivers. The last one is other element is commercial items, process specific, country specific, or combined with these technical things. The other cost elements are commercial things. Yeah, SG&A, sales, general and administrative cost. What is your profit? What is that ICAC cost, inventory carrying cost? What is the material overhead? What is the rejection? All other things it will be involving in the commercial aspect. We can say as other cost or cascading cost. All three put together, it's coming as a product cost, should cost, could cost, would cost, activity based cost. Many different methods are there. We don't want to go and get the confusion, all the terminologies. Focus on only should costing. Moving to next. Here we are coming to the process. Each and every should cost engineer, they should understand the should costing process. As we discussed previously, cost elements, those cost elements is coming and playing the three important factors. One is raw material, other one is process cost, the third one is overheads. It's equivalent of should costing. Should cost is a bottom up approach, best in class process, and ideal costing methodology. We don't want to go and discuss what is bottom up, what is top down. Yeah, simple concept. If you want to build the cost, you should understand the each and every element with calculation, with proven process, with justification. We can say it's a bottom up approach. Top down, yeah, management, they decided this could be our product cost. Take an example of Tata Nano. It's a top down approach. Yeah, 1 lakh I should make the product into market to service the people. Tata Nano, 1 lakh product. It's top down. Already they fixed that. Based on that, they are going to design each and every element. Then they are going to serve. But bottom up, you should understand the reality, understand the practical. This should cost is a bottom up approach. Take an example: material cost, process cost, and overhead. First, we can focus on material. The layman example, because most of the things are women's. So we are more interested to buy the product in the dress. It's a common example. If you know, if you go and buy the dress in the market or shop, they're having some price tag, might be $10, $12. You know what are the three components? Raw material and the process and the overheads. What is the raw material? If you go and buy 1 meter cloth, nylon cloth or cotton cloth, some cost will be there. That is your raw material cost. Please simply understand. You are going and buying 1 meter cloth as in nylon or cotton or silk. That is raw material cost. Process cost. That raw material you are going and giving to the one of the tailor. They are going to stitch and complete the shape, whatever we want, what is the measurement. The tailor, they are going to manufacture the dress. There it will be involving three important factors. The tailor, we can say, is a labor cost. The tailor who are doing that work, there some cost will involving to the manpower cost, labor cost. You understood that labor cost. Then machine cost. The tailoring machine you should invest might be $1,000 or $100 or $10, $20. That is your investment. Based on that, you have some machine hourly rate. You have the labor hourly rate. I'm going to pay for this candidate 400 rupees per hour. At the same time, whatever you're investing your machine, the tailoring machine, you have some hourly rate. That is your machine hourly rate. Then you know the cycle time. This cycle time, labor, machine, it will be determine your process cost. Yeah, tailor is there, tailor machine is there, raw material is there. He should manufacture the product. He is going to do some activity in that machine. Might be he will take 1 hour to produce this dress or 2 hours. That is your cycle time. Simple layman example. I'm not going and touching in the engineering part. It's well known example of how we can understand this cost drivers or cost element, how it's coming from, where it's coming from. It's easy to understand. Labor is the tailor, machine cost is the tailoring machine. How much time is going to spend and to produce that particular dress, that is your cycle time. Maybe take an example. 1 hour is going to take to produce that dress. His labor rate is $2.5. The machine cost is $4.5. Example: 2.5 plus 4.5, $7. He's spending 1 hour. So it's easy to 1 hour into $7. It's a process cost of that particular dress. $7 is the process cost. Then already you know that raw material. This 1 meter, it might be $0.5. Now you understood the three elements: material cost and process cost. Process cost is $7, material cost is $0.5. Example: $7.5, you come to know the details. Then you are going to do others cost, other cost, cascading cost, overheads. You are not doing a business, a service. You are investing some money. You are taking the big factory. You are paying the rent. You are paying the electricity, all other consumable things. You are paying your staff. You are paying transport, X and Y, Z. All other commercial things going to involve like SNA, R&D cost, rejection cost, inventory carrying cost, material overhead, profit, all put together, some numbers it will come. Might be 10 percentage or 15 percentage. It will be vary the industry, process to process. Take is approx 10 to 15 percentage all put together in this overhead. You have $7.5. multiply of 15 percentage, that is your should cost or product cost. I think now you got the clarity. The same principle you can take it some of the engineering part, take an casting part. Aluminum is the raw material. The raw material we can say is a 2.5 $3.5 per kg. That part it's going to manufacture to the engine component. The raw material going to melt into the furnace, pouring to the cavity, manufacturing as a casting part, then going to do machining, then going to do inspection. All each and every process it's going to involve some kind of movements, cycle time or activities. Everything it will be calculated as a process cost. Then already I told you the overheads, then you are adding some percentage, then you are getting that engineering product cost as casing commodity. We have different commodities. This should costing it's applicable from simple things to advanced things. Like you can able to do the should costing the pickles to spacecraft parts. You can able to calculate what is the pickle cost. At the same time you can able to calculate what is the spacecraft cost as well. This is a common methodology process. It's a method, it's a tool, it's approach. It's a domain wherever we can understand the importance of the process, we can it will change that. Wherever I manufacture pickles, that is the less value item. Wherever I do that spacecraft aircraft parts, that is high value item. At present we are focusing on the high value item. That is the reason this concept came from DOD, Director of Defense from US. They are manufacturing the high value items. They should understand the cost, how we can able to make it as a cost effective product. That's the reason this should cost came from. Now it's spreading to across all the manufacturing. Wherever you have the manufacturing product, manufacturing process, this should cost default it will be applicable. If I'm the mechanical engineer, civil engineer, electrical and electronics engineer, should cost is common. Yeah, if I'm the electrical engineer, yeah, you can do the motor, some other hardwares. If I'm the electronics engineer, I can do PCBA, electronics cost, electronic podcast. If I'm the mechanical engineer, I do all mechanical item. If I'm the aeronautical engineer, I do all kind of aeronautical. The commodity, the process, it will be little bit variance, but concept is same. Raw material cost, process cost, overhead cost, it's equivalent of should cost. We can name it anything. You can name it as target cost, directional cost, product cost, should cost. Many names are there, but the concept is same. One can determine the product cost based on what is the raw material they used, what is the process they followed, what are the other costs. A simple example. Maybe you can use tool, you can use template, Excel based, but the concept is same. Little bit variant in the accuracy level. It's not common. If you're using the tool, if you're using the Excel, what is the level of understanding about the knowledge, about the person, about the commodity, about the experience? Based on that, your should costing quality will vary. I think the concept is understood. We'll move to the next. Should cost in R&D. If you see every manufacturing, we have R&D, we have manufacturing, we have SCM. R&D it will be involving to generate the ideas, generate the product, invent the new product, design the product. There in R&D design, 70 to 80 percentage cost can be determined. If you take it, how it will be applicable, where it will be used in R&D, you can understand the target costing or design to costing. What are the material substitution cost, process substitution cost, raw material optimization, future optimization. The future means the process, the different features are there. Like casting process, we can do it 10 different process, 10 different features. The same thing we can optimize to the casting to forging. The future we can change that. Engineering catalog items, design to cost, design to value. In the R&D, this should casting it will be applicable for variant methods process. At the same time, it will move to the should casting in the SCM, supply chain management. It will be helpful to different place, cost out analysis, markup validation, markup margin, supplier negotiation, enhance your supplier process, competitive bidding, engineering catalog items, best in cost country. These two things we should understand very clearly. This should costing concept, should cost engineer is a service provided to the SCM, sourcing, buyer, category manager, cost engineer. They will estimate the cost. They can analyze the entire elements in the different methods. They will tell, hey, this is the product cost, this is the should cost. You can go and discuss with your supplier. You can go and talk to supplier to enhance their process. They're following something, this process, casting process, this particular pouring operation or melting operation, it's making more cost. Go and tell them to streamline, go and tell them to optimize, go and tell them to optimize, because this is the biggest cost drivers in this particular process operation. Those kind of visibility it will be bringing with help of should costing. Now you understood R&D, how they are taking the help with help of should costing. Now you understood that SCM, then where at all it will be applicable. Even if you know this particular component, where I can manufacture, what is the best country? Is that manufacturing China or India or Germany? Yeah, China is the best country, or India is the best. How you are going to determine? Yeah, India is the low labor cost compared to Germany. I can make it in the India. How much? Yeah, you can make it in India. What is the your transport cost? What is the packaging cost? What is the incoterms? Those things it will be clear cut ideas it will be bringing to the table while applying this should costing approach. What are the key skills required for this should costing? As a should cost engineer, he should know or he should have that skill set to analyze the cost analysis. Like already we told, as a cost structure, raw material cost, process cost, other cost. Then you can understand, yeah, this sheet metal item, raw material is occupying 60 to 70% of the cost. Process is coming 20 to 25%. Other cost is coming 10 to 50. This kind of understanding should be there. It will come based on the day by day, what you are working, where you are working, what are the component. Then it will be easy to understand the cost analysis as cost drivers. This skill sets is required to start doing the should costing. Then industry knowledge. Yeah, you can understand, if I'm the mechanical engineer, I should know what are the manufacturing process in mechanical engineer. If you are that electronics engineer, you should know how this PCBA manufacturing, how this the 360 different operations are involving to manufacture one chip. The industry domain knowledge. I cannot do PCBA costing, for example, you, because I'm not a domain expert. I supposed to know the process. I should know the what are the technique, what are the machines they're following. Then technical expert that relevant to the manufacturing process, what we discussing now. Then supply chain understanding. Why it should do this should costing? You should understand where it will be applicable. This should costing concept, it will be applicable to helping to R&D, helping to SCM. SCM, each and every year they are going and asking to the supplier, hey, please reduce 1%, 5%, 10%. Yeah, they will reduce one time, two times, second year, third year, fourth year, they will tell, yeah, sorry, I cannot able to go down. My hands are tight. I don't have any visibility to go down. those place, if you take as a should costing, you could do that should cost calculation. See, you have 10 percentage gap. What is the real cost should be, but your manufacturing cost this much. This is the cost. Is the open book calculation. You can showcase in front of your supplier. At the same time, if you do the R&D part, you can tell them this concept, this idea, this much cost should be. At the initial stage, they are not clear what are the process they are going to follow. You are the domain expert, you are manufacturing knowledge, you are the cost understanding, you are cost driver understanding. Then you can tell them, your R&D engineer or design engineer, hey, this is the raw material cost. If we follow cotton, silk, wood, steel, aluminum, copper or gold, this much your raw material cost. Yeah, if you follow the casting, machining, sheet metal, welding, or PCBA manufacturing or assembly, this much your cost. And this is the clarity, this is the understanding you can give it to your R&D team, and you can give it to your sourcing team. Then moving to the communication. If you know about all those things, you can boldly go and discuss with your supplier to bring down their cost. You should explain to the technical cost in front of supplier, then you can able to achieve your cost savings. Even supplier also sometimes doesn't know what is the real cost based on their experience. Yep, this part might be $10, $20, but they should understand what is the reality. How much cost is going for my raw material, how much cost going for this particular machining process. They should know that. It's not only helping to the customer, it will be helping to the supplier. So it's a common process for both of them. Customer should understand how much I supposed to pay for my supplier. Supplier should understand how much I charge from my customer. There it will be bringing that very big clarity in the should costing process. As a should cost engineer, you should acquire some skill set, then you can able to play in the big role in this domain. Already I told in the beginning, the cost engineering. The cost engineering is a big department. Simply I will take it the cost out programs. Maybe the DTC, design to cost, value engineering, value analysis, DFA, design for manufacturing and analysis, SCM, DTV, design to value, lean manufacturing, Six Sigma. Wherever you go and do the cost out program, should cost is default. You are cooking the food, how the salt is important. The similar way should cost is important for all cost out activities. Without salt, the food goes to somewhere. Without should cost, you cannot achieve the right cost out program. Should cost is the default program to get that cost benefit, cost improvement. I think now you understood very clearly why I should do should cost, why I should improve my knowledge in should costing, what are the elements are there in should costing, what are the tools, what are the process. Then we are moving to important slide. Why should cost engineering for women's? I can say lot of reason. Even I can make it very small. Diversity of the perspective. Women can bring a unique perspective about whatever they do. Even I would share. You know who's the top leader in shootcasting? The top leader of the company. It's driven by women. Yeah, please go and check it. You can find out who's that person. Yeah. So women is playing the key role in this market, in this shootcasting area. I'm reporting to my VP. She's woman. So don't keep it in your mind. It's a male dominated domain. No? If I take current organization, more than 30 to 40 percentage, they are running better than men. They are running this concept better than men, better than me. Yeah. It's a learnable skill set. It's easy to learn, but you should understand the funda. You should understand the method. You should understand the proper things. The next, talentful expansion. Encourage the women they can expand easily in the talent pools across the range of the skill set. Role model, the inspiration to others. Increase the collaboration in the team and getting the good performance. Women can lead in the project management, cost out program. Everywhere they can work across the team, they can make more collaboration. They can bring the high performance. The final one, equal opportunity and empowerment. As I told you, there is no barrier. This skill sets only for women, the skill set only for men. No, this is common for everyone. This is, yeah, shareable things. This is the learnable skill set. This is easy to do that. Very simple concept, I would say. Raw material, process, others. Other cost, you are not going to do anything. Raw material cost, 60 percentage you are getting it into the market. Are you doing something for, hey, what is that 1 meter cloth cost? No, it's not required at present. Yeah, 1 meter might be $0.5. That's it. Your raw material cost is over. Already I told you the process, the other cost. Yeah, you are not going to do it in much more details. Your finance department, or you have some standard ratings, you can take it. Only one key element you should understand: the process cost. Process cost also, it's very easy apart from only one element. Yeah, you know the labor cost. Yeah, the tailor cost, the tailor per hour might be 250 rupees. Yeah, you know that. The machine, yes, the investment of the machine, you can tell that hourly rate. And final one thing, the cycle time, the how much time is going to produce. That is the key element you should understand. Then this concept is very clear. You can play the big role in this domain. As I mentioned that it's not only for customer, it's applicable for supplier as well. It's not only for the mechanical, it's applicable for every manufacturing. If you want to manufacture this cap, this headset, this should cost is necessity. Even you can make it from pickles to spacecraft. The concept is same. The domain will vary. The process little bit change. Don't hesitate to enter in this should costing domain. We are always welcome to work with this should costing field. I am very happy to support whoever required for this skill set. Wherever I can expand my experience, this is the opportunity to bring them back. Moving to the next, the conclusion slide. Yeah, already we have discussed many things. Shootcasting is the valuable tool for validating, optimizing the product cost. Now I'm bringing little bit some technicals. Yeah, product cost. If I want to manufacture this particular iPhone, they already know what is the real manufacturing cost. Then adding all other commercial cost, then it's coming to the market. You know, 10,000 rupees the cell phone, the manufacturing cost might be in the 4,000, 4,500, not 10,000. How they're understanding the 4,000 or 4,500? With applying this cost calculation, this should costing approach. It involves the systematic approach and understanding the cost reduction opportunities, entire the lifespan of the product. If you are manufacturing some new R&D product, yep, then you can understand what are the elements. Once you understand and manufacture, then you can streamline, make it the lean. There also you can apply the should costing concept. Yeah, the first year my product cost is $10. Might be the next year I can automate, then I can bring it down. My product cost $8 or $9. Should costing start during the product design and manufacturing, and it will be impact of the entire value chain. It will be helping to identify the big cost saving opportunities. You want to meet in the target market, you should know the proper should costing of your product. Collaboration among the cross functionals already we discussed. It's helpful to discuss with all across. It's not only should cost engineer involving and determine the product cost, the design engineer, R&D engineer, manufacturing engineer, SCM, testing engineer, everyone it will be collaborated to build this cost. Should cost engineer it will be working with all across the team, identifying the cost drivers and explore the cost opportunities while alternate the process. Like I told you, the one of the example, casting to forging, forging to machining, sheet metal to plastic, we can alternate the process and get that cost benefit. Should cost enhance the competitive, profitable customer values. Something you are manufacturing, are you selling the right product to the market? Is it worth for that market, that product? If I'm going and buying something, I'm paying the right price to that. This should will help you to understand, are you paying the right price to that product, buying that? It will give you some clarity if you understand the approach or method. Implementing the should it's required some cultural shift, mindset mindset and collaboration. As I told you, it's not only the male dominated things. Yeah, it's common to do that. So understand the little bit technicality, understand the funda, then you can do it. You should change that mindset, implement this should costing, get that cost benefit. Yeah, thank you very much. Few open available links, you can go and refer, you can understand much clarity on this topic. Now the question and answer time. If you have any questions, yeah, feel free to ask. I'm ready to answer. Is there anyone you can chat in the message? Then yeah, I'm able to answer that. No more question. I'm waiting for a lot of questions. Huh? If we have no more questions, yeah, we are good to close. Yeah, you can reach out to me to get that details. Please.
Yeah, hello. Thank you so much. That was really, really amazing, and it was very insightful and gave us so much clarity. And it was, especially encouraging for you to touch upon why women should engineer should costing as well.
Yeah.
Thank you so much for your valuable insights and your advice and sharing your knowledge with us. We are truly grateful. And yeah, if anyone has any questions later, if you just want to take some time to kind of reflect on this,
Yes.
please
Yes.
do
Yeah.
feel free to reach out. We'll also help you get in touch with Mr. Kuppusamy if needed.
Correct. Yeah. So we can happily close the session. You can reach out to me wherever I can able to expand. I can share some kind of information. I'm willing to do that. Thank you very much giving this great opportunity, specifically working for bringing back women to shoot casting. Thank you very much.
Thank you so much for joining us.
Thank you.